the next session is about the TIES working groups. And this is an initiative that was organized and promoted by the TIES TIES membership committee. And before to introduce our great speakers, I would like just to give you the context of this experience. So in 2021, the TIES membership committee launched an initiative to improve networking and to create a collaboration across the society members. And essentially what the committee did to contact 3 international leaders and ask them to lead on the work of 3 working groups. Currently, the groups are bringing together researchers from North America, India, and Europe. And they have made not only a significant contribution, and this contribution will be highlighted in this session, but also they represent a successful example of virtual collaboration. So today we have here all the 3 leaders of the initiative, and I'm going to introduce and to welcome the 3 leaders. What I'm asking you is to hold your question till the end, because we are having 15-20 minutes of discussion that will be also facilitated by the other member of the TIES membership committee. So without further ado, I'm going to introduce our first speaker. It is Matt Wheeler. Matt, I cannot see Matt. Are you here? Yes. Matt is a scientist. Great. Is a scientist in the Biostatistics and Computational Biology board at the National Institute of Environmental Health Science in USA. And Matt is going to talk about mixed Bayesian compressed regression for multivariate models for larger correlated geospatial datasets.
Thank you. And originally you had asked me kind of to talk about the lessons learned. And when I got that, I originally was thinking that was for next summer. So when I wrote that, that was like what we're talking about next summer. So I kind of wanted to talk about the whole process and what we've done and kind of the lessons learned from it and all the group and everything. So that's, thank you, Monica, and thank you all. So it's really been a great experience doing this, and I appreciate the ability to talk about this and even the ability to lead one of the groups. So before I do anything, I want to give a special thanks to all those people actually in the working group. This was just as it came to my mind in no particular order. So Wesley, Burr, Monica, Jonathan Stroud, Ben Swallow, and Ed Boone. Those are the ones that have kind of stuck with me throughout all of this. And we've been, you know, learning together on how to do this whole process. So for me, I wanted to say, well, the starting philosophy of this was for me, research is always open-ended. I never know where I'm going when I start. I just hope to go in a direction and have the science take me there. So when I started the idea, you know, Susan Simmons actually contacted me, and I think it was April or May of 2021, asking me if I'd be interested. And I thought the best way to do this was that research is an open-ended endeavor that is best done when all people are engaged creatively adding their ideas. So I wanted to facilitate a working group in this way. Now, I have learned since then, and I think everybody would agree, but this is going to be challenging with Zoom and multiple continents. And at one point we had, I think, 5 time zones. It gets really challenging. And so really kind of I want to talk about what we were doing and how this kind of impacts everything. So really we started, and I wanted to compare Bayesian methods for Gaussian random fields with application of spatial statistics and fast Bayesian methods. So the big problem with any sort of regression, but really when it comes to Gaussian processes and Gaussian random fields, is that you have this matrix that you need to invert. And if you do just classic methods, that inversion is an n-cubed operation that takes a significant amount of computer horsepower. And it usually tops out around 1,000 or 2,000 observations. So that really is very small in the data sets we're dealing with nowadays. And how do we deal with spatial regression and do all of these other things when we have this Gaussian random field that we have to put in? And it's basically, if we were to talk about it initially, we were talking about not days or weeks, but years and decades to run your Gibbs sampler. That becomes a problem. So realizing this, there's been a lot of state-of-the-art work that has been done recently. And I was fortunate enough to help a graduate student, Kelly Moran, who's now at Los Alamos National Labs. And we were able to develop a in-log-in approximation with some pretty nice bounds on the sampler. And the whole idea was I wanted to take this method, compare it to the state-of-the-art out there. And so this is actually, it's still in press. It has been accepted in JRSSB. What we did was we developed a Gibbs sampling method for hierarchical matrices to estimate just a general function. Now, my background and her background, we're more in the machine learning space. So our standpoint, we take smooth functions and we want an exponential kernel. And we compared our results to SP and NGP, which is essentially the more gold standard in terms of the spatial literature. And for a large N in a paper, we outperformed that in mean squared error by about 12-fold, which is huge. And even to the point where a reviewer felt that we were doing something wrong with our analysis. And we went to the actual authors of the package and worked really hard to show we weren't making anything wrong. But it really led a question: how do we kind of go back and forth and figure this out? But also to note that if from a frequentist perspective, Chen and Stein found something very similar with their version of hierarchical matrices, because our method and their method is based on something called an H-matrix. And they were looking at smooth functions. So we were both looking at smooth functions. So with some playing around, this difference kind of goes away as the process becomes rough. That is, as the Gaussian process's kernel becomes more exponential. So we actually have seen, and this is some people in the working group as well, have seen that NGP does seem to outperform FIFA-GP for such processes in initial tests. So I'm a person more pragmatic than anything. I want to say, well, given no method is probably best in all circumstances, it's really of interest to see what recommendations can be made. When can you use one method over the other? What is driving the bus when it comes to these approximations and their fidelity towards the true process. So here is kind of the thought here. I had this conversation with a graduate student a couple days ago where she said, well, you know, she's reading a book, I think it was written in the 90s, and the fundamental statement was use matern. And it was from the spatial statistics literature. Well, the spatial stats is a very specific group of people that do work a lot, and they use the matern almost exclusively, and there's nothing wrong with that. But it's still kind of a very almost dogmatic statement. And then on the other hand, in the machine learning area, we just love to slap down the squared exponential for everything. It's the go-to kernel that people will use in making these Gaussian processes. So those two kernels really change how the process behaves, and if you have a rough process or a smooth process. But as you start to get a lot of data, the reality is what we really want is a good estimate. And the pragmatist part wants to say, well, we need to think about what is actually working, what is going to describe the data we have the best, and how do we leverage what we know to do that. And sometimes it's going to be absolutely clear that our process is going to be very rough, and assuming some smooth function is not necessarily going to be helpful. But there's other cases where you have a lot of data and it's reasonable to assume a smooth function. And in those cases, a rough process is not going to be helpful. So it's kind of good to know when things break down and when things go from one process to the next. So we started last year in early October, and we started to meet on Zoom. The initial meetings were to see what people's interests were and what direction we wanted to take. Remember, from the initial ideas in terms of my philosophy, I want people to be able to contribute, but I also want people mostly to be able to contribute in their creative capacities. So initially we had 3 continents: Asia, Europe, and North America, 5 time zones, and a mix of postdocs and established researchers. We haven't ended up there, but that's what we started with. So in convening this, I wanted to say, well, what should we do? How should we go forward? And then the first step was, well, I had to explain a JRSSB paper to a mixed crowd, and that's going to take some time. I just can't have one meeting for an hour and expect everybody to be on the same page of the theory and the other things. So that was my first goal, to try to get everyone on the same footing and to go in one direction, but that was going to take time. So we found out that there's kind of some issues: group dynamics, determining the exact direction of the research, and keeping the early career researchers engaged. So for group dynamics, Zoom calls about research with people you know is one thing. If I know the person or have dealt with them in the past, it's pretty easy to have a group start up when you are meeting these people face to face, or you have known them because you know what they're presenting, you know what they add to the table. And in this whole group, there was only one person I knew, was Ed Boone, but everybody else was new to me. So I didn't know everyone's skills, directions, or research interests. So that's going to be very challenging to have my initial research philosophy, and I really didn't think that through. So you add to the fact that you have a Zoom call with a new group, it's going to be even more challenging. And leading such a research group is especially so. So when you sit down, there's a really, in this post-COVID world that we live in, where we have all of these Zoom meetings, there's really, I think, a thirst, for a lot of people just to sit down over a meal, over a beer, and talk about what they're doing. And that brings research together really fast in my experience, because, like it or not, we're social animals. So in this case where we just jumped into Zoom calls, I think it was a little out of my element in trying to start such a thing. So there's no substitute for face-to-face, but you can learn about everybody's abilities and interests eventually. It takes time, but it's really hard to lead that type of research group at start. So determining the exact direction. So when you're able to do such a thing with a Gaussian process, there's a million different questions you want to ask. And as a kid, and I still am, I always liked the Choose Your Own Adventure series books. It was just, I get to decide. And I love it when the people involved help decide the direction. That's kind of how I work. I'm very egalitarian in that sense. And you had to figure out what people like in their research, where everyone was going. And we have a mix of researchers. We have people that are specifically devoted to spatial statistics. We have people that are very computationally oriented, and we have people that are kind of a jack of all trades. So simply put, other people have ideas too, and they need to be heard. But on the other hand, some people are looking to make a quick impact. And this was kind of one of the struggles we had initially, and I still think that was where I kind of dropped the ball. Because if you're looking to have a quicker impact, and at the same time you're saying, okay, here are the things that we're doing and here's the direction we're going, let's, get a good idea where we want to go. What we need to do is keep engagement. This is something I failed on. I failed on it because it seems that a lot of the early career researchers were looking for more of a research program where they could just jump in and contribute immediately. And especially with what we were looking at, it was developing a model, it was doing these things and trying to figure out where we wanted to go first. And that took a series of probably October through December-ish. So that's really kind of where I think I lost some of the early career researchers, and they ended up leaving the group. So given the first issues, this made them less interested, and they kind of really just wanted some impact, and they kind of moved on. So, okay. Now, after we got our footing, the step is to do the analysis. Now, everything I do tends to have massive simulation experiments attached to it. How does one distribute that in a group that has uneven computer resources? And by uneven computer resources, is you never really think about how the other person is doing their simulation. You never think about how someone else is going to do this. You just say, if someone says, hey, do this simulation, you know how you would do it. And when you have a bunch of research software packages, you find out that they don't always work as advertised. And I'll talk about that. And then HPC environments are different depending upon the institution. And this is a big one too. So we've had numerous issues just getting other people's and my code to run. SPN and GP likes to crash when the kernel is too smooth. Now, this makes it difficult for simulations because you set it off, you go away for the weekend, and you come back and you didn't get one done. And what happens is there's an issue in the SPN and GP code that once the matrix in the diagonal, it has a diagonal band matrix. Once those matrices become less than full rank, everything breaks down and you can't use it. It just crashes. Now, on the other hand, the code that we have for the fast Gaussian processes, it requires a much more intimate knowledge of R package building. And I don't know if you've been on CRAN's website recently, but it's not always the best resource to go to when you're trying to figure out how to build an R package. So we had to work through, Wesley, fortunately, is brilliant when it comes to working with packages, getting this together, but it requires a more intimate knowledge to tell everybody, okay, this is how we get this started. And that actually took a lot of time because we have all sorts of different people coming to this from a very different perspective. Now, you wouldn't think about it initially because everybody I usually work with is at the same institution. So as I am, so they all have the same HPC. And we're all working on the same high performance computing. So if I give you code to kick off a batch job, it's going to work because it was written for the same thing. Now, that is not the case when you're doing something internationally. And everybody has their own way to access their own high performance computing environment. And the way to share code doesn't always work. HPCs from different institutions are set up totally different, and they have totally different parameters. And we have spent hours trying to figure out why one code piece of works on one computer and will not work on another. For instance, this simulation we're running, we're getting them all finally kicked off. And last meeting, we had a situation where there were essentially what took 8 minutes to run on my Macintosh did not finish in 72 hours on someone else's computer, HPC. And I was like, that's pretty insane. And the reason was in their HPC environment, there were debug calls that were set that were basically saying every time R threw in the garbage collector. And you had to know physically how to turn that off and the other thing. So essentially, once R's garbage collector is being called and you know every time, it grinds your computations to a halt. But this, again, is a problem. You can't just give someone code and they can't just give you code and have it expect to work on a research environment. So when it comes to computers, assume it's going to go wrong. Then step 3, write the manuscript. And there are problems here: collating information and determining writing assignments. And in terms of collating information, this goes back to the computer issue. Everyone uses different computer resources and has a preference on how to deposit the data. Here it's Google versus Microsoft in a way. I initially set up a Microsoft OneDrive that everybody could dump stuff into. However, a lot of people have Microsoft accounts for their email. And you might know that a Microsoft account causes problems to access other people's Microsoft accounts when you get these tokens. So we had huge issues there just with the logistics of it. And Wesley was kind enough to share his Google Drive, which is actually where we're depositing data now. Microsoft is not friendly for a lot of people. And now this is the final thing that I kind of talk about, is determining the writing assignments. Now, it doesn't seem like a problem because if you're like me, you work on teams where everybody does the writing and it's not a big deal. But again, everybody here usually that I work with is, I'm in Research Triangle Park. Most people are local to me. So I can just go down to NC State. I can go over to Chapel Hill. I can just go over to the EPA. But everybody is on a very different schedule. Europe seems like late summer vacations, holidays is when you take your vacations. In North America, we like them early in the summer. And the US has Thanksgiving next week. For instance, I'll be on a boat in the Caribbean starting tomorrow. So when you are planning to write and update and do these things, it becomes a little bit more challenging to think about. And see, it's really a question of what can people do when, and everybody has very demanding schedules, especially since a lot of the postdocs decided not to stay on, which was unfortunate. Now, things that I would do differently. one of the big things, I would meet one-on-one with each person before the large group. That would allow me to understand where everyone's coming from, what their interests are, and how the best they could contribute with the research question. I think that was something I took for granted because of the fact I'm used to dealing with people one-on-one or in person, which allows me to understand the situation. But it has been a learning experience for us all involved, and we're on really good footing right now. I think the simulations are coming back very interesting and resulting in I think a really interesting work. I think we even have a pre-doctoral student that's interested in continuing some of the work and joining us, although she kind of felt out of place when we were talking about the bug issues on an HPC the last meeting. So I'll have to meet with her a little bit before to gear her up for when we continue. But overall, it's been a very positive experience of moving forward and trying to get this global statistics environmental community to work together. And I think as I go forward with this and some of the other people that get involved, we'll be better able to help trainees as well as postdocs with their research. So thank you much. And I think those were all the citations.
Thank you so much, Matt, for this fascinating talk.